We're going to talk today about adding Perl to your tool belt, or as I think the talk's actual topic title was, "Don't Bash, You've Got Perl." Right? This was an alternate cover sheet that I thought of using. Perl is the worst programming language except for all the others. Signed, Larry Wall. Or there was this one also that I kind of liked because that's kind of an inside joke, I guess, for Perl. I run Salt Lake City Perl Mongers. We have a website, saltlake.pm.org. We have monthly meetings where we discuss Perl or things tangentially related to Perl. So if you're interested in that sort of thing, go ahead and take a look at that. And who am I? My name is Dave Oswald. I studied econ and also computer science at the University of Utah way back when. And I work for EIG, locally known as Bluehost. I'm on their enterprise orchestration team, back-end developer. I consider solving problems my hobby, but I also get paid for it, which is nice how that works out. And our goal today is to learn how and why to get started with Perl. Oh, I actually gave this as a 2-day thing last year, and so we're not doing a 2-day thing. In about 2 hours is what we're going to try to do here. I know this is supposed to be workshop, and we're going to try to do some workshop-y type of stuff, and also some of me talking. We'll go back and forth and see if people start bailing out, then I'll realize I'm doing too much of one thing and try to shift over to some of the other thing. So you might be thinking, but why am I here? Why are we talking about Perl? It's an old language, right? So C first appeared in 1972, and most recent standard was 2011, Java 95. Perl came on the scene in about 1987. Its most recent release is for a production-ready version is 5.22, which came out this year. So what conclusion can we draw by saying that, but it's an old language? What conclusion can we draw? The answer to that is we can't draw any conclusions based on the age of the language. Okay, let's just dismiss that right now. Okay, how about this one? Syntax is ugly. You've heard this, right? Perl's syntax is ugly. And I don't know, maybe that's right. But here's some quotes that I found on the internet. I'm supposed to learn blank for work. It's really bugging me. I don't think I've ever seen such an ugly programming language. Objective-C. I don't know. Okay, so how about this one? The homoiconic nature of blank means that one cannot tell by looking at the code alone whether something is data structure or a function. You have to read and understand the context. Other languages make it pretty clear. Okay, that could be Perl, right? But it's Lisp. So, all right. So you can't draw any conclusions based on the syntax. Do we need to talk about C and C++? They are not beautiful either, right? We can't draw conclusions based on the perceived syntactic beauty. Beauty is in the eye of the beholder. That's if you happen to ever play Dungeons and Dragons, like back, when you're younger or whenever, that's the beholder up there. How about this one? You maybe have heard, Perl lacks subroutine signatures or named parameters. Okay, but who cares? This is Perl. This is a different paradigm from whatever other language you're coming from. So let's not get hung up on that. And besides, starting in Perl 5.2.0, you can actually use a feature called signatures, and you can define your subroutine signature. So we can dismiss that one. That still leaves us with the question of why Perl? Why we're here talking about Perl today. And so let's talk about the 3 virtues of a programmer. Does anybody know what the 3 virtues are? Just, you don't have to yell them out, but raise your hand if you know what they are. You don't know. So there was a 1497 painting by Andrea Mattanega, and it's called The 3 Virtues. And I guess the 3 virtues up there are justice, temperance, and fortitude. But that reminds me a lot of Superman, justice and temperance and fortitude, and that's not the 3 virtues of a programmer. So we'll cross that out. The 3 virtues of a programmer, this is Larry Wall, he invented Perl. The 3 virtues of a programmer are laziness. Laziness is the quality that makes you go to great effort to reduce the overall energy that you expend. So it's kind of paradox, right? Laziness. Another one is impatience. Impatience is the anger that you feel when the computer is being lazy and not doing something that it really ought to be able to do. You become so impatient that you decide to do something about it. And then the third one is hubris. And that's the best picture I could come up with for hubris, although it's probably false hubris. But anyway, hubris is the pride that makes you write and maintain programs that you can be proud of. Doing things that you can be proud of, and you can be proud of being a coder or being a developer. So laziness, impatience, and hubris are the three virtues of a good programmer. And I should qualify that by saying appropriate laziness, appropriate impatience, and appropriate hubris, because there's a difference between that and false impatience, false laziness, and false hubris. So who am I? I've already given you the slide of who I am, but most of all, I aspire to be lazy, impatient, and hubristic. Is that a word? Yeah, hubristic. And so why Perl? Well, because Perl was developed with that kind of a mentality that let's get the job done without a lot of fuss, and let's make it possible to do cool things without working too hard. Right? The other reason why Perl is that, like Vim, you've got it. It's just about everywhere nowadays. It doesn't ship with Windows, but you can install it in about a minute, and everything else it ships with pretty much. With Perl, you can get the job done quickly. You can be expressive, powerful with finesse. And for me, anyway, I'm a Perl developer, so for me, it's fun. And there are a lot of other reasons. It's powerful, it's fun. One of the reasons is something that we might talk about a little bit later called CPAN. Anybody know what CPAN is? Yeah, the Comprehensive Perl Archive Network, I think is what it stands for. And it's a collection of over 10,000 different libraries that people have developed and written tests for and put up for others to use. Sometimes people will tell you that CPAN is really the language and that Perl is the syntax that the language is implemented in. One of the philosophies of Perl is that easy things should be easy and hard things should be possible. So how do you obtain Perl? Does anybody here have Perl on the systems that are in front of them? Or, yeah, most of the people, hopefully. It's often already installed. That's kind of hard to read, but just which Perl, and it'll tell you you've probably got it at least one place on your system. Or you could type Perl-lowercase v, and it'll tell you what version you have on your system, or what version you're currently running. There are many other ways to obtain Perl. So often it's already on your system. You can use package managers if you're running a Linux distribution that has package managers. You can use the package management system usually to download a version of Perl. People who are a little bit more hardcore will usually use something like Perl Brew. Perl Brew allows you to install a local version of Perl just under your user. And not just one, but you can install many versions of Perl just under your user. You can install Perl with threads support, Perl without, Perl 5.18, Perl 5.20, and you can readily switch between them very easily. So Perl Brew, http://perlbrew.pl. I find Perl Brew very convenient when I'm trying to write code that targets multiple versions of Perl, because it's very easy to switch between them and just test that it's doing what it's supposed to on each. If you're running Windows, any Windows users in here? We can skip this slide. Okay, we have a Windows user. So for Windows, I typically use Strawberry Perl if I'm using Windows, strawberryperl.com. There's also Active State Perl, Active Perl. No, I have a slide for that. There we go. That's probably enough evangelism. Becoming productive with Perl. There are some great books available if you decide that Perl is something that's interesting to you in the long run. Learning Perl is one of the books that I think just about everybody who is a Perl programmer has read at some point in their lives. Intermediate Perl is a pretty good book. Modern Perl is actually a free book that you can obtain online. If you just Google for Modern Perl, you'll find it. But one of the best resources is Perl's own documentation, which you can read either immediately on your system or at perldoc.perl.org. For a while, I was doing a lot of work in C++, and I found this quote from Straustrup that I thought was really good. What you must do in any language is pick a subset, get working, writing code, and gradually learn more of the language, its libraries, and its tools. That coming from Straustrup, he invented C, or he wrote C++, created C++. That really is kind of the Perl way, right? Just get going with something, get busy, get writing some code, do cool things. So we're going to try to learn a subset of Perl. We're going to learn a little bit about structure, data types, operators, lexible variables, loops, conditionals, subroutines, files, basic I/O, using objects, and if we have time, a little bit of CPAN. We might not have time for the last couple at the end there. We'll just see how it goes. As we start, one of the best resources that you can use is Perl's built-in documentation. So if you have a terminal in front of you and you have Perl installed, type perldoc Perl intro. And if you type that, then you should get, essentially, this is an HTML version of it, but this document. All of Perl's built-in documentation is available through perldoc. You'll end up typing perldoc Perl intro, and then there are other ones that you'll get into later, Perl syn for Perl syntax, and so on. But a good starting point, Perl intro. And I like to tell people that are asking questions about Perl and how do I do this, how do I do that? Well, spend 20 minutes reading Perl intro and then come back and ask me, because that's all I ask. 20 minutes with Perl intro, and it's going to whet your appetite, it's going to give you a little bit of a basis. So that's a good place to start. But not right now, don't do it no reading while I'm talking, no, just kidding. Okay, so the format, are you guys able to see this from back there? Yeah, you can see? Okay, good. So Perl is a scripting language, and as with many scripting languages in Linux, you're going to start off with a shebang line. User bin env Perl is how I typically run Perl on my system, because env respects the settings that I use with Perl Brew. Perl Brew sets the environment and sets up which interpreter env should find. Comments start with the hash symbol. You can use libraries starting with the use keyword. Constants are also set up using the use keyword, and then your application for world domination goes after all that. That's kind of your basic header up at the top there. So what does an obligatory hello world look like? It's going to start off with USR bin Perl or USR bin env Perl, whichever shebang line you like to use, and then print hello world \n. This isn't Pascal, you have to put the \n. And that's it. You save that, set that as executable, and invoke it as .hello, and that's you've written your first program. Anybody want to try that? Is anybody able to do that? Make it actually work? So in Perl, lines end with a semicolon, or statements end with a semicolon. It is case sensitive, so print needs to be lowercase. And if you don't want to do all that typing, these are command line alternatives. So right from the Linux prompt, whatever prompt you have, Perl-E, and then in single quotes, print double quote hello world \n and with a single quote. So this is a script that you would write and save versus this is just being a command line argument or a command line. If you have a relatively modern version of Perl, modern meaning within the last 8 years, then you can use capital E and the word say instead of print. And when you use say, you don't have to append a new line at the end. So anybody that's followed along, that's your first Perl script. Thank you. Okay. in modern times, even the last 15 years, Perl developers have preferred that you also use strict and use warnings. Strictures and warnings we'll talk about a little bit later, but put that at the top of your script, get in the habit of using those two tools. If you want to be really strict, then you can use things like AutoDie and diagnostics. Diagnostics is best for when you're developing something. You usually ditch that once it's ready for production. So be strict, be modern. If you use a modern version of Perl, use feature 522, then you get a bunch of new stuff that Perl introduced in the last, in whatever version that you specify of Perl. So anyway, that's the basic structure. Now let's start into talking about containers. And when I talk about containers, I mean things that contain data. The first type of container that Perl has is something called a scalar. When I'm talking today, I'm kind of coming from the direction of thinking that most people in here have had somewhere between a little bit of scripting exposure to a whole lot of programming exposure in some other language. We're somewhere in between there. And so a container, we're going to say that's a variable is a container, and a container can hold something. And in Perl, a scalar container can hold a single thing, a number, a string, a reference to something else, but a single thing. And that's what a scalar is. In Perl, scalars start out with something called a sigil, and that sigil for scalars is the $sign. So right here, I'm declaring a variable, my num equals 1. Num now contains the number 1. Perl doesn't care if your container, as long as it's holding a single thing, it doesn't care if that container is holding a number or a string or a reference to something else. It's not a strictly typed language like you would find with Java or C or C++. It's a dynamically typed language or a loosely typed language. Other types of containers, the next one would be an array. You can think of an array as a container that holds a list of things. And that list doesn't have to be any specific type of thing. It just has to be a list of scalars. So here we have my things, which is, array containers in Perl start with the sigil that looks like the @ sign. I guess @ looks like an A for array, okay? So my things equals this, that, and the other. So now we have 1, 2, 3, 4, 5 things in this array. My refs, here we have an array called refs that's holding references to scalars. And here we have, and here we're just going to print the 0th thing, which would be the first thing in things, and that's going to be this. Arrays in Perl are homogeneous. So in a language like C++, you would declare an array or a vector or an array or a vector or whatever other container to contain a bunch of elements, and those elements will all be one thing. In Perl, your array can hold whatever you put into it, a bunch of single things. You can put numbers and you can put strings. Again, because Perl doesn't make a strong distinction between numbers and strings, it doesn't matter what you put into your array as long as it's just a list of things. The next type of container, if you're coming from, anybody here know PHP? Okay, PHP, I think that Perl's hashes are probably the closest to PHP's actual just kind of arrays, because that's a language where the keys can either be numbers or strings, I believe, right? I could be wrong about this because I'm not strong with PHP, but in Perl, a hash always starts with the %, and then it contains a list of key value pairs. So seat is the key, and the value that seat has is 5. HP is the key, and its value is 250. Fuel is a key, and its value is reg. And if we were to say print the car has set HP, what is HP? HP is 250, so it's going to print the car has 250 horsepower. Print there are, if you want to know how many elements are in your hash, then you use the keyword scalar and the keyword keys, and you would say scalar keys set, and that will return the number of elements in the hash. And so here we have 1, 2, 3 elements, and so that's going to print 3. You can assign the list of keys, the keys here being seat, HP, and fuel, to an array if you want. My key names equal keys set, so keys serves the function of returning the key names. Or you can return just the values if you want. My values, which are 5, 250, and reg, here vals is going to be assigned just the values from this hash. So Perl's 3 different types of containers, it really only has 3. They serve every purpose that Perl needs, are scalars, which are single items, arrays, which are lists of items, or containers that hold lists of items, really lists of scalars, and hashes that contain collections of values, which would be scalars, indexed by keys. So whereas an array is indexed by numbers, a hash is indexed by keys that are just plain old words, whatever words you dream up. If you're coming from a language like C++, then you would be talking about aggregate containers. Aggregate containers would be arrays and hashes, and then you have scalar containers, which contain single items. So the sigil that I mentioned before expresses the container type. I should have a ladder here. I won't do that, I'll fall. The sigil expresses the container type. So the $ expresses that that is a container that holds a scalar. The @ sign expresses that that container named array holds an array. The % expresses that this variable contains a hash. But when you're looking at an individual element in an aggregate data type, you're looking at a scalar. If you want to look at the 5th, actually that'd be the 6th, but the number 5 element in array, you're looking at a single element. A single element is a scalar value, so you put a $ in front of it. Am I going too slow? And we're not going to go too deep into references, but you can have arbitrarily deep data structures just by using references. Here we have a hash with the keys, names, and age. And those keys each point to a reference to an array. This array has the values 30, 26, and 46, and then the array pointed to by names has Bob, Frank, and Joe. You can have an array of hashes, data structure, a hash of hashes. So there's plenty of, you can combine your aggregate types just by using what we call references. Perl has a couple of special containers or special variables. We call them topic containers. The first one is $_. And this is something that confuses people sometimes. $_ is a special variable that under certain situations contains a value. And you simply just have to get used to knowing when those situations are. In the context of a for loop, which we'll talk about loops later, the topic variable just gets the value of whatever element you're iterating over in the for loop. In subroutines, the topic variable is the @_, which means an array. And all of the elements that are passed into the subroutine, all of the parameters passed into the subroutine are stored in the $_, in the @_ variable. And we'll look at that again, we'll look at that a little bit later. So there are many functions that operate just by default on the $_ topic variable. So here we have the statement print $_ for 1 to 10, and that's going to print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But you can omit that $_ because print implicitly will act upon $_. So here just print for 1.10 will also print out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because print implicitly operates or implicitly looks at $_ if it's not passed some other parameter. In a special case, we'll look at file handling later, but this is reading from a file and reading the contents line by line of a file into $_ also. So now we've talked about container types. What about Perl's data types? Well, Perl doesn't really make a strong distinction between different data types. Internally, it has representations for different types of data, but externally, from the programmer's point of view, you typically don't have to worry a whole lot. You have strings. Strings have to be put in quotes. You have numbers. Numbers don't have quotes. If you want to express a hexadecimal number, it'll start with a 0x. These are literals, literal 42, literal 3.14, literal pi, whatever. This would be a literal octal, 0655. So in Perl, strings are quoted and numbers are not. The astute viewer here might notice that I've used single quotes and double quotes. There's a small difference, but for the purpose of creating a string, both work the same way, except that in this example, the double quote makes it so that the \n gets interpreted at its semantic value of being a new line. If I had used single quotes after hello world, then I would have gotten a literal \n in my string instead of a literal new line. There are other types of literals we won't deal with in great depth right now, but references are created by using braces or square braces or curly braces, file handles, type globs. These are other types of Perl data types. Perl data types do what you mean. So Perl is a language where data types themselves are polymorphic, but the operators that act upon the data types are monomorphic. So the operators that act on the data types tell the data whether it should be a string or a number. So if I say the string 42 minus the number 42, Perl is going to automatically convert this string into the number 42 and then subtract 42 from it, and my answer will be 0. So the operator here has told Perl to treat this string as if it were a number, and the conversion happens implicitly behind the scenes. On the other hand, if I take the number 42 and I look at the substring, the 0th position, which is the first position in the string, the first position in 42 is 4. And so here I've taken a number and treated it like a string, and Perl just automatically treats it like a string, doesn't care. It handles the conversion implicitly behind the scenes. The string 0 equates to Boolean false, just like the number 0 would. Which brings up a strange topic, and that is Booleans. The number 0 is false in Perl. The string 0 is false. The empty string is false. A special value that we call undef, which means no value at all, is false. Everything else that is not false is true. So for example, the string 0e0 is actually true. Equates to Boolean truth. In Perl. This is Exter Dijkstra. He invented Pascal and Modula 2. And he was very strong on structure in programming. He would probably hate Perl. But Perl does have structure. One way of implementing structure in Perl is with subroutines. So here I'm creating a subroutine add, and I'm going to stand on my stool here this time. $_ gets whatever parameters I pass into add, and I'm going to assign those parameters to a variable, an array called param, and now I'm going to add the 0th element and the first element of param and return that value. So there's a subroutine that adds the first two parameters passed into it. Here's a factorial subroutine. Anybody that's taken a CS 101 class has seen factorial, and this is a recursive version of factorial. So to call a function in Perl, you call it by using parentheses, the function name parentheses, and then passing in some parameters. Perl also adds structure by using namespaces. You can create packages, package foo, subbar, rbaz, package main has access to foo baz. But if I were to, from package main, just try to reference baz without fully qualifying it, I would not get any value because it's a separate namespace. This is kind of a whirlwind tour. We'll go into more detail in a minute. Package globals. You can declare global variables with the keyword our. That's my family. Our family, Dave, Eileen, Nathaniel, and Noel. Within the same package, I can access that variable print family, and it'll print my family's names. Or from outside of the package, I can print main family. I can print the package that it comes from and the variable name, and it'll do the same thing, print the family. How do you do loops in Perl? There's several kind of loops. One is for each. For each my item in list, print the item. So what this is going to do is walk through each item within the array list. When it gets to the first item in list, it'll assign that to this variable named item. And then it's going to go and print that item. And then it's going to go grab the next item in list, assign that to item, and then print the item. That's a for loop, a for each loop. A for loop looks like the old C-style for loops. My I equals 0, I is not equal to 10, I plus plus I, print I. That's going to print 0 through 10, or 0 through 9. And here's a real shorthand way of doing things. Say $_ implicitly for 1 to 10, and it'll print 1 through 10. That's for loops, for and for each. Those are actually synonyms for each other. For and for each can be used interchangeably. We have while loops. So while rand5 is greater than 3, print unlucky. Or print as long as there's something to be printed on the input file handle. Do something while this condition is true. Print 42 until this condition becomes true. So these are all versions of loops. And we're looking here at one of them that's a prefix loop where the while is at the beginning, and then we have some postfix loops. Do something while at the end. Perl also gives you the, in C you have break and continue, in C you have break and next. I can't remember all of a sudden, but in Perl you have next. So next we'll move on to the next iteration. It'll stop right where it's at, move on to the next iteration of the loop. Last we'll stop the loop altogether and break out. And then finally, we want to look at files. To read a file with Perl, you specify the file name, myfile.txt. You specify the file's mode. We're going to read it. That's what that less than sign is for. You give a file handle that we can use to access that file stream. And then you go ahead and within a while loop, you say while there's something on that input file handle, assign it to line, get rid of the new line, that's what chomp does, and then print that line. So here we're just gonna, that's like cat, we're just gonna cat a file, essentially. Perl also offers conditionals. If, else, if, else. That's pretty common in every programming language, many programming languages. There's also, Perl also offers unless, which is kind of the opposite of if. Unless some condition is true, unless some condition is true, go ahead and do it. Go ahead and do this. It also offers postfix. So call this subroutine snore if sleeping. Sleep unless time is greater than wake up time. So you can use postfix conditionals as well. And then there's also logical short circuits, continue and live. So as long as continue is true, then live will also get called. Or if continue is true, then live will get called. So I mentioned before that Perl has polymorphic data types, but monomorphic operators. You think of a language like C++, and you would declare or define operator plus. You might create operator plus in one, that when given two numbers, it adds them together. When given two strings, it concatenates them. That's C++. With Perl, the operator does not take different data types. The operator tells the data what type it is. So the operators themselves are monomorphic. So you would use, for example, the less than sign up there to compare two numbers, equals equals to compare two numbers. But if you want to compare things at their string value, then you use LT, EQ. So you have numeric relational operators and string-wise relational operators that treat their operands with different semantics. Yes, go ahead. That's correct. Yeah, and so that becomes relevant if you're looking at the opposite. For example, like if you're using a numeric operator on a string and a number, and the string has a 0 in front of it, that 0 is going to disappear, right? When in the numeric comparison, and so yeah, you get string semantics with the string operators, numeric semantics, and it doesn't matter whether you're passing a string or a number. Perl's going to treat the number as a string or the string as a number here. Yeah. Perl also has this concept that can be kind of tricky, and that is the concept of context. Things behave differently depending on whether they are being looked at in scalar context or list context. Sorry, I'm getting a little dry. So if you look at an array, which is a list of things in scalar context, you're not going to get the first element off the array. You're going to get a count of how many elements are in the array, because the array in scalar context evaluates to its number of elements. Whereas if you look at the array in list context, assigning an array to an array, it's going to move all of the elements or it's going to copy all the elements into the elements array there. But here, in this case, this is a different type of a case. My item, the QW operator, treats what's inside of it as though it's individual elements. So it creates a list. The list is A, B, and C, 3 elements. And in scalar context here, it gives you the last element in the list. So here, that's a common pitfall. Arrays in scalar context evaluate to the number of elements, but something that looks like a list in scalar context is just the last element of the list. Here we've put this item scalar inside of parentheses, which tell Perl to treat it like a list, and we're going to assign A, B, and C to that list, and it's going to assign A, the first element of the list. So there's some gotchas there, obviously. So an array in scalar context lists the number of elements. A hash in list context will give you a flattened out list of the key and value pairs. In Boolean context, it'll tell you whether it's empty or not. For each loops impose list context on their condition. While loops impose scalar context. So context is kind of a tricky topic, and it's one of those things that you have to kind of fiddle with and experiment with and learn about as you're learning Perl. Then another thing we want to look at is scope. And scope is something that's pretty familiar to most structured programming languages. My foo inside of this block here is different from the foo outside of the block. So if I'm up at the top, I'm setting foo equal to 10. Inside the block, I'm setting it to 100. And then I'm going to print it. It's going to print 100. Now out here, I'm going to print foo again. Well, we're outside of the block. It's reverted back to its 10 value. So these are literally two different variables. The foo inside of the block is a different variable than the foo outside of the block. The block does absorb the environment around it. So if I didn't declare my own foo inside of the block, then printing it would print 10. And then just to make things even more confusing, Perl has a lot of what we kind of look at as functional programming type of concepts. Map, grep, sort. With map, we take an array or a list, numbers, and for each element in the list, we apply this transform of the element times 5, and then we assign that new list over to times 5 here. And so now every number in this numbers array is going to be multiplied by 5 and written back out to the times 5 array. Grep is a filter. Anything that matches a certain condition, the condition that we set up in here, will be filtered through, and sort will take an unsorted list and sort it and pass it back out. And this led to a Lispism being kind of brought into Perl called, decorate, sort, undecorate, or decorate, transform, undecorate. This is something called a Schwartzian transform. We won't worry too much about it. Let's look at regular expressions. Anybody here use regular expressions with any frequency at all? Yeah? And now you realize that you have two problems, right? That's I'll use the regular expression. Well, now I have two problems. You can't save the world with regular expressions, but we are going to look at them and figure out what they are a little bit. In Perl, regular expressions are built right into the language's syntax. You don't actually call a match function or a substitute function. There are actual operators built right into the language that operate, that take a pattern on one side, and on the other side take the item to be matched against. So here we're going to take a scalar variable named string that presumably contains some sort of a string, and we're going to match it against a pattern. We use the equals tilde operator to perform the match. And the pattern is contained in the m/pattern/. And the pattern syntax should be fairly familiar because Perl's regular expression syntax has become very ubiquitous. There's a PCRE library for just about every language nowadays, it seems like. Substitutions, you take string, you test a pattern against it, and if that pattern matches, you'd replace the part of that pattern that matched with replacement. So there's a substitution that'll do a substitution right within a string. If you use Vim, then you're probably familiar with pattern matching and with substitution. In Perl, if you don't provide a string to match against, Perl will automatically try to match against $_, whatever happens to be in $_. So, and it'll also try to substitute against $_ if you just do a substitution in the absence of any bound variable. But you can also just bind any variable you want. We're going to here bind string against pattern, perform the match. String against pattern. You don't have to, the M is an optional. M tells Perl that this is the pattern matching operator, but even that's optional. S is not optional. So here's an example of evaluating a, a pattern match in scalar context, or Boolean context, really. If string matches hello, then print hello to you. So if our string starts with the word hello, then it will match and it will print hello to you. You can perform captures by using parentheses. Whatever is matched inside of the parentheses will be captured. Captures are captured into special variables, $1, $2, so on. So here, the string A, B, C, D, E, the A is going to be matched by the first set of parentheses, the B by the second, the C by the third. We're going to go ahead and print those out. $1, $2, $3, we'll print those things that matched and were captured, and we get ABC. There's a thing called the G modifier, and that allows the match to happen many times. So A, B, C, D, E, we're going to match just a single character and capture it. We're going to do it as many times as possible inside of a while loop, and each time through the loop, it's going to print what it captured. So the first time through the loop, it's going to match A and print A. The second time through the loop, it's going to match B, and so on. And now we're going to move off of regular expressions quickly and look at Perl's core modules. Perl comes with a lot of modules built right in. One of them is, for example, list utilities. To use a built-in module, you'd say use, and then the module's name, and then whatever function or functions you want to import from that module. And then you can just go ahead and use that function that you've imported. And now CPAN. CPAN modules can be found by searching on search.cpan.org or on metacpan.org. And to install a module, you would simply type cpan install. This is at the command line, cpan install, and the module name. And then you go ahead and just use the module. Use Modulicious Lite, for example. Right here, we've created a little mini web application in 4 lines by using the Modulicious module. So this is kind of the end of the first talk. I have a couple of, we can take a little break for a minute. Future reading, if you want to look at learning Perl, intermediate Perl, programming Perl, modern Perl, but most important, the Perl docs that are built in, starting with Perl intro. You can sometimes write faster code in C, but you can always write code faster in Perl. So we could open up this up to Q&A, or let's take, or if you want, it's almost been an hour, we could take a little break and then come back and look at something else. Or you can escape. If there's anybody still here in 5 minutes, then I'll keep going. We can. Well, just to let you know, so this first thing that we went through is like a whirlwind tour where you're not supposed to actually remember anything, right? And now, if you come back after the break, or you can escape, but if you come back after the break, then we'll start looking at individual aspects in a little bit more detail and hopefully try to remember a few things. So this was supposed to be, oh, the workshops may have been a separate, I think they were only by torrent, maybe. However, I will put these up on SlideShare at some point, and I can give you a way to, I'll tell you what, the Salt Lake Perlmongers website, I run that website anyway, so I will put a link to these slides on that website. So saltlake.pm.org. Yeah. I'll put a link to these slides. I'll have it up by within a couple days. Yeah, sure. We'll give a couple more minutes and then I'll start again. Am I back on again? Yeah. So for the next few minutes, I'd like to go in a little bit more detail into Perl's data types, variable types, operators, context. Let's see. And if you're looking for reference materials on what we're going to talk about for the next few minutes, Perl intro again, Perl doc, Perl data. So if you were to type Perl data at the command prompt, and also Perl op, which stands for Perl operators. So Perl's concept of plain old data types. Integers can be represented in any of these ways. One thing that might be kind of surprising is that you can put underscores in integers. Sorry, I'm losing my mic. So this is 1 billion here. The underscores have no semantic meaning. They are simply formatting that you can use to make your literal numbers in Perl legible. Trying to make this thing stay on me. Okay, there we go. Anytime a number starts with a 0 in Perl, it's treated as an octal. And anytime it starts with 0x, it's treated as a hexadecimal. And hexadecimals are case insensitive. So it doesn't matter if you use lowercase or uppercase f, or even a lower uppercase x here. And anytime it starts with a 0b, Perl treats what comes after it as binary digits. Floating point numbers are just constructed using a decimal. And again, it's perfectly acceptable to use the underscore if it helps you to read the number more clearly in your code. And then there's strings, and that's where things get a little bit more confusing. Strings that are quoted with double quotes will expand meta characters. And so in this case, the meta character is \n. That represents a new line. Strings with single quotes will not expand meta characters. There's another difference that we'll talk about a little bit later. Here we're using double quotes because we have some meta characters here, and then we're using 0x and then embraces a hexadecimal number, and this becomes a code point. That would be like a Unicode code point for 30CF, whatever that happens to be. I don't know what it is. You can also specify code points with just the \x and its decimal value. There should be a backslash in front of the 0. And you can also put literal Unicode characters within a string, single or double quoted. So here we have hola, using a character that's above the 127. And there are other types of plain old data types that we won't get into, references, type globs. We'll forget we ever mentioned type globs. They're entries into the symbol table. So variable types we talked about before a little bit. Scalars always start with a $sign. And so if you want to think about what the mnemonic is for that, the $sign sounds like which is the first letter in single thing. And you can assign any single thing that you want to a scalar. The number 42, the string hello world, the literal float pi. You can pass undef, which means no value, or even an empty string. For array, you think A for array because that is like array. And that's a zero-based sequence container. And then you have hashes, which I don't really know what the mnemonic is for the %, but % designates that you're looking at a hash, which is a key value store. You can call defined. The defined function on the scalar will return the Boolean value whether or not a scalar has a value. Ref, whether it's a reference. Length. Length will tell you if a scalar value has length. So if a string has characters in it, then length will have a number of characters. If it has nothing in it, then length will be 0. In Perl, arrays grow dynamically, kind of like vectors in C++, except even more dynamically than that. So here we're pushing Sam onto the array. So Sam becomes the next element added to an array over at the top there. Here we're popping an element off of the end of the array. So we pop Sam right back off and assign it to the scalar element. You can unshift, which puts a value at the beginning of the array. And you can shift, which takes a value off of the front of the array. So by saying shift array, if the first element of the array contained the word yes, it would shift yes off of the array into this scalar element. I guess in C++, push would be most analogous to pushback. Okay, for hash utilities, you have the keys keyword. The keys keyword will tell you all of the keys that a hash contains. So this hash here contains honest and Abe. Keys will pull out those two keys. Or in scalar context, it'll tell you that there are two elements, honest and Abe, too. Values will work on the values here instead of the keys. It'll tell you that you have two values, 1 and 1 up there. Print yes if exists, hash honest. So here exists asks the hash, does this key honest exist? And if so, then this condition is true and it'll print yes. So the sigil describes the entity that you're looking at. So dollar for scalar, @ for array, and %sign for hash. But if you want to look at just one element of an array, you're looking at a scalar value. And so you would use $array and then the subscript for that element that you want to reference. But if you want to look at the array as a whole, you'd use the @ sign or a hash as its entirety using the %sign. So here we're just assigning hello world to greeting, and then we're printing greeting. Here we're assigning lists to arrays, 46, 42, 53, to ages, and then we go ahead and print ages. Perl has this interesting thing called a hash slice. With a hash slice, you can print more than one, you can grab more than one element out of an array at a time. And here we're going to get the first element and the -1th element. What would that be? Well, the -1th element tells Perl to start counting at the end of the array and go back 1. So now we're pulling we're pulling the 42, which is the number 1 element, and the -1 element, which is 3. Kind of a strange thing. You can use negative values to count backwards into your array, or to index backwards into your array. Here's another array example where we're going to assign hello to greeting and world to subject, and then we're going to assign greeting and subject into intro, and intro now contains the words hello and world. You can reverse an array just by using the keyword reverse. So intro equals reverse intro. Well, what does it now contain? Instead of containing hello world, it'll contain world hello. Here's a hash example where we have keys and values, and then we're going to print class size for CS201. CS201's class size is 50, so that's going to print 50. So here we're just using the key to index into our hash. And if we want to know how many keys are in the hash, there are 3 scalar keys, is going to tell us 3 courses in the CS department. So you can also create a list. This is possible with Bash also, I guess. You'd use a hyphen. But so 1.4 is actually going to create a list of 1, 2, 3, and 4, and then go ahead and assign that to the array. And then you can take a slice, which is taking just several elements out of the array. We're going to take the 0th through the number 2 element out of the array and look at those. The 0th is 1, the number 1th is 2, and then the second is 3. So that's a slice where you grab several elements at once out of the array. Another way to do it would just to specify specific elements. 0 and 3 is going to give us the 1 and the 4 out of our list. And you can take hash slices too. So here, our new hash is going to contain key 1 and key 2. It's going to contain the key 1 and then the value key 2. Anyway, truth and falsehood. So the number 0 is true, the string 0 is true, the empty string is true, and undefined, I'm sorry, false. All of these are false. The number 0 is false, the quoted 0 is false, the empty string is false, undef is false, but everything else is true. And then in context, we talked about also, I'll pass that because we talked about that earlier, but here in list context, we're assigning 1, 2, 3, and 4 into an array. But here we have scalar context because it's just a scalar variable, and so we're going to just assign the last element to that scalar. Operators supply context. So 1, 2, 3, 4, that looks like a list, and 4, 3, 2, 1 looks like a list. But what's actually going to happen is it's going to take the last element out of each of these lists and add them together and give us 5. There's actually no such thing as a list in scalar context. Perl takes this construct right here and just grabs its last element because it's in scalar context, and this construct and grabs its last element because it's in scalar context. So these actually aren't even lists, excepting your code. But once Perl sees them, it treats them just like scalars. No lists in scalar context. The keyword scalar can be used to supply context. Let's look at operators. So for math, you have just your basic operators, plus, minus, times, divide, modulo, and the two asterisks represents exponentiation. You have plus, plus, and minus, minus, just like in many other programming languages. And then you have the plus equals, minus equals, which are used for additive assignment, just like most other programming languages. In some languages, you'd use the plus operator to catenate strings, but in Perl, remember, the plus operator is a numeric operator, and if you were to apply the plus operator to 2 different strings, it would try to treat them as numbers, so you wouldn't get catenation. So Perl has its own catenation operator, which is the dot. So here I meant dot, I didn't mean period. But it is the actual, period, whatever, on your keyboard, but the dot is used to catenate 2 strings. So here we are catenating the string in first, and then a space, and then last, using those dots. Sometimes it becomes inconvenient to use quotes because you might find that you have to escape them with backslashes if you want to embed a quote in what you're in your literal string. So Perl lets you use alternate quoting constructs. QQ with slashes is the same as double quotes, and Q with a slash is the same as single quotes. And QW is the same as quoting each of these 3 things with single quotes individually. So QW, it actually stands for quote word, and it means to turn each of its space delimited things into individual elements in a list. So that's a 3-element list that looks like this, that, and other. And then we have relational operators, the numeric ones, the string ones. That one up there they call the spaceship operator, and that is less than, equal, or greater. That operator returns -1 if the operand on the left is less than the operand on the right. It returns 0 if the two operands are equal, and it returns 1 if the operand on the right is the greater one, something like that. And the string equivalent is CMP for that. So if Todd is string-wise greater than Dan, then say yes. And it is actually greater because T comes after D. And then you have logical operators, not, or, and, bitwise operators. These are pretty common to other languages. And the ternary operator, which is condition, question mark, the yes expression and the no expression. You'll find that in C, C++. You find it in many other languages. In list context, a comma creates a list, and in scalar context, all of the left-hand operands are discarded and the right-hand one is returned, which is similar to C. So Perl is heavy in what they call do what I meanery. Perl's objects dictate how Perl treats the value. Plain old data types take a backseat to the operator's semantics. So as we talked about before, say quote 0 plus quote 1 will treat 0 and 1 as numbers. Say 1.2 will catenate those two together as though they were strings and return and print 12. Say sum. Now quote word puts each of these in quotes like they're strings, but what's the sum of 42 and 42 is 84, and that's what you'll get. So do what I meanery. Most operators are monomorphic. So in numeric context, 0, 0 is the same as 0. In numeric context again, or in string context, 0, 0 is not quoted, so that's a number. It still becomes 0 to Perl, and then it's turned into a string and equated, and 0 and 0 string-wise equate to true. But here we have these two are being treated as a number, so 0, 0, 0 numerically is equal to 0, true, but 0, 0 string-wise is not equal to 0, false. So when a numeric value is interpreted as a string, you get something that we call stringification. So here we're taking 42 and concatenating it with a string, so we're treating it as though it were a string and it becomes stringified. And nummification is the opposite, where you take a string and treat it as a number, it becomes nummified. Like everybody in this room, right? Okay, so the nummification rules can be kind of hard to remember. If the string starts with a number, then the part of it that is a number becomes its numeric value. So here we're nummifying 98.6 normal, the string, by adding a 0 to it. That nummifies as 98.6. Again, minus 40 also nummifies as minus 40. But here, normal it starts with a non-numeric string, and Perl nummifies that just as 0. It doesn't know what to do with a non-numeric string, so it just treats it as though it were 0. Here we have a scientific notation number, and that gets nummified even though it has a string at the end of it to Avogadro's number. So I've said this a bunch of times. Numbers are monomorphic. Operators are monomorphic, and data itself is polymorphic, which is opposite of most other languages where the operators are polymorphic and the data types are monomorphic. So reference material for this: Perl intro, Perl data, and Perl up. And do you guys want to try writing some code? Or do you want to talk about something else? It's up to you. Let me tell you what we'll be talking about next, and then you can decide. We're going to be talking about conditionals and loops. Should we just go into doing that? Okay. I can go either way. Otherwise, you could write a Morse code translator. Your choice. Okay, we'll go into talking. Sorry, you have to listen to me a little bit longer. So we're going to explore Perl's conditional control of flow constructs, its looping constructs. We're going to understand scoping semantics a little bit more, and we're going to finally learn to program a little bit with Perl. This is what we're all here for. Reference material for this segment of our, if you want to call it a workshop, is PerlDoc PerlSyn, which stands for Perl syntax. It's not very well named, but I can't think of a better name for it either. So if you were to type at your command prompt PerlDoc PerlSyn, then you would get the documentation for what we're going to talk about. The basic if statement, if condition, then execute this block. And that would look identical in just about any imperative language, I think. So here's an example. My random equals 1 plus int rand 6. If random is equal to 6, then print we got a lucky roll today. So we just rolled a die up there. And if the roll up top there came back as being equal to 6, then we'll go ahead and print a lucky roll today. You can append an else block. So if the condition is true, execute the first block, and if it's not, then execute the second block. So an example of that would be the same thing. We'll roll a die up top there. My random equals 1 plus int rand 6. If random equals 6, then print a lucky roll today. Otherwise, print you must narfle the Garthog. That's from Coneheads. So, here we're going to do an else if. If random equals 6, then print a lucky roll. If random equals 7, print you are free to go. Obviously, that's not even possible. Otherwise, you must narfle the Garthok. And you get the idea. You can have as many else if conditions as you want. If condition 1, execute block 1. Else if condition 2, block 2, and so on. And the trailing else is optional, but you can put it if you want. So that is if, and many languages have if, not many languages have unless, and there's a good reason for that, because it can become very confusing very fast. Almost like double negatives can become confusing, right? Unless you're really lucky, narfle the Garthok. So with unless, you're only going to execute the block if the condition is false. Right, unless it's true. Yeah, that's right. You're only going to execute the block if the condition's false. You also can have postfix conditionals. So here we were looking at if condition, then block. But now we're going to look at block if condition. Although it's not really a block, just statement if condition. Print narfle if bad roll. Print go free if good roll. Postfix conditionals. And that's a shorthand that you find being used a lot in everyday Perl programming, everyday code. And even unless can be a postfix conditional. Print remain captive unless lucky roll. With short circuiting, the expression on the left will be evaluated, and if it's true, then evaluate the expression on the right. You can use the symbolic and or the word and. They have different precedents, but aside from that, they have the exact same meaning. Here, expression on the left, if it is false, then if it is true or false, if it is true, we're going to stop there. If it's false, then we're going to go through and try the one on the other side. So expression or expression. Either this one is true or that one is true. So you can use short circuiting. You can actually use short circuiting for control of flow. If roll equals 5, if it's not equal to 5, then narful. You can use it like an if statement. If it's not equal to 5, then narful. Don't ask for switch in case. Perl doesn't have it. Well, it didn't have it up until 5.10, and then somebody introduced it, and then they realized what a terrible idea it was, and they did away with it again. So Perl doesn't have switch in case, and you don't need it. Loops. For loops are sometimes called C-style for loops, for each, while, and until. So a C-style for loop looks just like it would look in C, almost. My index equals 0, while index is not equal to the number of elements in an array, then increment index and go ahead and print that array's element. So there's a C-style for loop. Oh, that's my brother and sister. Perl also has for each loops, which have become fairly common. In fact, even C++ got them with C++11. For each element in array, print that element. So print Dave, Dan, and Shannon, one after the other. Hello, Dave. Hello, Dan. Hello, Shannon. We try to favor this style of for each loop rather than the old C style for what hopefully are kind of obvious reasons. You say Perl's syntax is ugly, but I'm not so sure which is worse here. The C style is uglier, and we try to use the one that is more legible. So in this example, instead of using an implicit operator for each element, print it. We didn't define an explicit scalar container. Here we're going to say for each element in an array, put that element into the variable named name and then print it. So we've been explicit about the variable that is the topic variable of that array, of that loop. We have while loops, which are common in many languages. While 1 plus int ran 6 is less than 6, you remain in captivity, narful. And then as soon as that condition, it'll keep repeating and repeating until that condition becomes false. And as soon as that condition is false, you've been released. You're no longer in the loop. So just like we have unless, we also have until. And if unless was kind of a bad idea, until is really a bad idea. Because it's semantically or mentally, it's hard to keep track of what it means. Until this condition becomes true, keep repeating. A while loop is is repeat until the condition becomes false, but an until loop is repeat until it becomes true. So you occasionally will see that in Perl. It's available, it's not often used. And here's examples of postfix loops. So narful until 1 plus int ran, whatever, narful until that one becomes true. Narful while it is true, and narful 10 times, 1 through 10. And here's a postfix until using a do block. It's too many ways to do things. Say for each 1 through 10 is just going to print the variables, the numbers 1 through 10. And then we use control keywords next. Next, we'll move on to the next iteration of the loop. So if today is a holiday, then move on to the next iteration of the loop. If you've run out of tries, then last, exit out of the loop. Last terminates the loop like break would in C. I guess it's continue in C, isn't it? Next, the synonym for next in the C programming language would be continue, I believe. But Perl has its own version of continue, which is different, of course. And that is that here we have a while loop. And if you're next to the next iteration of the loop, or you last out of the loop, you're still going to hit the continue block before you move on. People don't use that too often, but it's available. And here's a little secret. For and for each are the same exact thing. So instead of saying for each element in Garthox, you can just type for. And so you'll see that a lot in Perl code. People get tired of typing out for each. There's no reason to type for each because for and for each are the same thing. Blocks have scope. So here, inside of this block, inside of the loops block, we're creating a variable named I. And outside of the block, we're trying to print I. That's not going to work because this I here that we created, it's my because it's while. You think of while as saying my I. That I exists only within the block of the while loop. Outside of the block, it doesn't exist. That's variable scoping. So all blocks have scope. You can fix that by creating the I outside of the loop. It's still available inside the loop, inside the loop's block, because loops inherit their surrounding environment. And so after the loop terminates, because you created the I outside of the block, you can still access it. It's still what we call in scope. Scope and flow. So here we're setting I equal to 0 outside of the block. We're telling that the last time we want to see this block ever is if I equals 10. We're going to increment I and print it. We're going to add I to an accumulator, and then we're going to redo. Redo is another form of a loop. It'll take any bare block and start back at the top of the block again. Redo, redo, just like a loop. We're back up to the top of the block. But then as soon as I equals 10, last will take us out of the block. And of course, loops nest. So you can have nested for each loops. For each letter A through Z, for each number 1 through 10, print letter number. That's going to print A1, A2, A3, A4, whatever. And then B1, B2, B3, B4, and so on. Nested loops. Inside of this loop, name will the first time through the loop will be Jane, and the second time Pete, and the third time Frank. But when you fall out of this loop, your inner scoped name ceases to exist, and the variable name reverts to the value that it had before the loop began. So real quick summary. We talked about if, else, conditional statements, unless, postfix, constructs, loops, blocks, scopes, and loops. Subroutines. We can look at, in the Perl documentation, Perl sub is probably the most important next piece of Perl documentation. Perl sub, so Perl doc, Perl sub. And also Perl mod. We won't deal as much with that. We're going to talk about namespaces just for just a second, and then we're going to be done with them, and we'll move back on into subroutines. My variables are what we call lexical variables, and our variables are what we call global variables. Package global variables have last names and first names. So package variables have a first name, the package that they live in, and then the variable's actual name, its last name, or actually it's the first name is pizza, and then the last name is the package that it lives in, main. That's slide 1 of package globals. Slide 2 is that inside of package foo, we can refer to pizza here, our pizza. Inside of package main, if we want to refer to pizza, we have to use its last name if we want to see the pizza that exists in package foo. That's all we're going to talk about in namespaces. Mostly we're going to talk about my variables. So we're going to look at a few things here. What's wrong with this picture? My value equals 100, value times equal minus 1, if value, my number equals 9 minus 75. I'll tell you what's wrong with this picture is that we're repeating ourselves a lot. So, and the other thing that's wrong with this picture is that by repeating ourselves a lot, we've gone ahead and made a little mistake here. A lot of copy and paste is a perfect time for mistakes to creep in. So why don't we do this instead? Each of these were supposed to be doing the same thing, multiplying a value and adding something, and adding it to something, times equaling something. So why don't we just make a subroutine that does it? Sub absolute, my value is shift, that takes the first element or the first parameter. V times equals minus 1 if V is less than 0, and return V. Now we've turned all of these into one subroutine that we can call again and again and again. Value equals absolute value, num equals absolute num, input equals absolute input. Call it again and again. We're not going to introduce mistakes. And we can even write tests for it using Perl's test more module. So subroutines are used to avoid repeating yourself. They're used to create abstractions so that you don't have to look at complex operations again and again. They're used to promote code reuse. We can even make that a little bit more elegant. Return if V is less than 0, negative V, otherwise return V. And we can test it using Perl's test more. So the important thing to remember is not to repeat yourself. Use subroutines. If you find something that you're doing again and again, don't copy and paste. Use subroutines to do it again, please. So the structure for creating a subroutine is you say the keyword sub, you give it a name, and then you have a block of things that are supposed to happen inside that sub. All of the parameters that were passed into our subroutine will appear in a special array at underscore. The last expression evaluated in the block will be the return value, or you can use the return keyword to make that return value explicit. So here's an example of a subroutine call. My return value equals foo with some parameters, whatever parameters you want to pass in. My return values equal foo, and you can pass in an array, whatever. Perl's parameter lists end up in $_. You can access $_ directly, each element directly. So here we're accessing the first and second element of $_. Those are the parameters. Or you can shift elements off of that array automatically, or you can assign left and right out of that array and then add them together. These are all the same. These all have the same semantic meaning. Yeah, each one has the same semantic meaning. Here we have sum of squares. My numbers are whatever parameters were passed in. My sum is 0. Sum plus equals $_ for each of the numbers, and then return the sum. So that's the sum of squares. So the sum of squares of 1, 2, and 3 is 14. That'll take an arbitrarily long list of parameters. Parameters are aliases until you unpack them. So as long as the parameter remains inside of $_, then anything you do to that parameter will propagate back out to its caller. So if I were to say the parameter plus equals 5 and then call add 5 n, n is now going to be n plus 5. So through osmosis, we've passed the value back out of the subroutine without returning it. Typically, we just return values. So subalphabet return A through Z. There's our return value. And you can also return nothing. If you just say return with nothing after it, then it returns nothing at all from the subroutine. Subroutines, because they are blocks, have their own scope. So in this subroutine add, n and m exist only within the subroutine. And then there's a thing that I refer to as global osmosis. Any block absorbs its surrounding environment. And so here, here our add subroutine is absorbing n and m from the outside world. We don't like to do that too much because it breaks encapsulation and is pretty ugly. References are something that are kind of confusing. In C or C++, you'd think of them as kind of a pointer. Other languages have similar concepts. Here, nameref doesn't contain name. It contains a reference to this variable name. Here, arrayref doesn't contain an array. It contains a reference to this array. And then you can, so here we have, here you can dereference name ref. Let's see, we're creating name ref, and you can dereference it just by putting an extra $sign in front of it. So what's the point to references? Well, they let you have, they let you solve problems of complex data structures. Here's an example. We have my n and my a equal $_. This will never work. And the reason that will never work is because n will absorb everything that's passed in from $_ and a won't get anything. Well, what if I want to pass two arrays to a function? Then you're going to have to pass them as references. My n and a is $_, that's not going to work. If you pass them with references, name array ref and a array ref, then you can go ahead, then they're not going to be flattened out into a flat list. And references also let you do data structures, lists of lists, hashes of hashes, hashes of lists, and so on. So here's an example. We're going to test using a function called isDeeply whether the array reference containing 1, 2, and 3 is the same as the array reference containing 1, 2, 3. And the answer will be yes. Those two are the same. They contain the same elements. JSON, here we have some JSON, and we're going to de-JSONify it. We're going to decode it. And this is what it would look like in Perl. An array, a hash, an array ref, a hash ref with some elements, another hash ref with some more elements. So a summary, namespaces are used for code and project scalability and reuse. We didn't touch too much on those. The general day in and day use case is not to really deal with them too much. Package globals are for special uses. Subroutines are the building blocks of code reuse. Subroutine blocks have their own lexical scopes, and references are used for building data structures. So I'd encourage you to look at Perl sub and Perl ref quick as two sources of information on references and also on subroutines. And I think that that's probably where we should stop. What do you guys think? Is that about enough? Okay. Because if you wanted to go on, we'd talk about map and grep and stuff like that, but I think that's probably about enough. We're all tired. So I want to thank you all for coming out. If Perl is something that's interesting to you, start with Perl Intro. Look at the Learning Perl book and also the free book online called Modern Perl by a guy named Chromatic. Those are good starting points. Why Perl is relevant to us here in this room, I believe, is because it's available everywhere, just like Vim. If you find yourself going to Vim because you know it's going to be on every box you touch, that's the same reason you should be going to Perl, because it's on every box you touch. And Perl that you write, Perl that was written 10 years ago for Perl version 4 will still run, actually that'll be 20 years ago, will still run today on Perl version 5, probably with very few changes, if any changes at all. Backwards compatibility is a big consideration with Perl. Any Perl that was written a decade, even a decade and a half, 2 decades ago will still run on modern versions of Perl. It won't look pretty, it won't be following modern day best practices, but it'll still run. So Perl is everywhere. It's part of the operating system almost for Linux and Unix environments, BSD environments. I hope that this gives you enough that you might feel interested in grabbing Learning Perl or grabbing Modern Perl, or at least grabbing Perl Intro and giving it a try, having some fun with it. And if you enjoy it, maybe someday I'll see you at a Perl Mongers meeting. Anyway, that's it. Thanks.